going to talk about trapezoids and kites. If you remember, parallelograms were everything that had two sets of parallel sides. Trapezoids have one set. Kites or general quadrilaterals have no parallel sides. Kites are like just one specific kind of general quadrilateral, but you could have anything with four sides can be a quadrilateral. It just so happens we're going to specifically talk about kites because they have some special characteristics. All right, so we're going to talk about trapezoids first. Trapezoids have one set of parallel sides, and they call these the bases. So these two sides are parallel. The other two sides are called the legs, and the angles that come up to make the bases are called base angles. So these two base angles and these two are base angles. All right. Now, trapezoids on their own can look like this, as long as they have two parallel sides. You can see trapezoids that look like that. But if I asked people to draw a trapezoid, they would probably draw this one. Draw one that looks like this. And that is an isosceles trapezoid. An isosceles trapezoid does have some special characteristics. One is that their legs are congruent. Okay? Their base angles are congruent. So this angle is congruent to this angle. Angle B is congruent to angle C. And its diagonals are congruent. So if you do in diagonals, they would also be congruent. Okay? And the converse is also true. If you have an isosceles triangle, then the base angles are congruent. If you have one pair of base angles congruent, then it's isosceles. Okay? Also, the diagonals. If you have an isosceles trapezoid, then the diagonals are congruent. If the diagonals are congruent, then it's an isosceles trapezoid. So it's a biconditional statement. A trapezoid is isosceles if and only if its diagonals are congruent. Remember, biconditional uses that if and only if, not an if then. And we show it by having that arrow that goes both ways. All right? So if I did a couple of these examples, if this is an isosceles trapezoid because we can tell the legs are congruent. So if this is 117, this is 117. All right, and if it's isosceles, these two are also equal. So that means out of 360, because it's a quadrilateral, this side must be 180, and this side must be 180. So that means these two angles are supplementary. So I can do 180 minus 117, which is 63. So this angle is 63, and this angle is 63. Okay? Same thing over here. 49, 180 minus 49 is 131. Right? Same thing here. I can set these equal to each other and solve. All right, a trapezoid mid-segment theorem, if you remember, in a triangle mid-segment, the midpoints are connected by the mid-segment. So that's a midpoint here, that's a midpoint. We call the line that connects them the mid-segment. It's parallel to this opposite side, and it's half the distance. So for instance, if this is 10, this would be 5. Okay, so to find the mid-segment, I would do 13.5 plus 8 and divide it by 2. Okay, so, and for this one, since we're going to, we already know the mid-segment, but we're trying to find one of the bases, we would say x plus 38, which is this base and this base, divided by 2 is equal to 31. So I would, to to solve this, I'd multiply both sides by 2. That would cancel that. So I get x plus 38 equals 62. Subtract 38 from both sides. So x would be 34. No, x would be 24, sorry. 24. All right, that's trapezoids. Then the last one, kites. There's a couple characteristics of kites. No sides are parallel, but the diagonals of a kite are perpendicular. So they make right angles, okay? And then it's consecutive sides. So like these two and these two are congruent. Okay, so the way I think about it is like two isosceles triangles put together. So we've got an isosceles triangle here and an isosceles triangle here. When you put them together, it makes a kite. Okay? And it's got an isosceles triangle, or a kite has one set of congruent angles, and those are the angles that are formed from one of the congruent sides here combined with one of the congruent sides here. So where they, one side of each of the pairs come together, those angles are the congruent angles. So where these two come together makes that angle, these two come together makes that angle, these are the two angles that are congruent. Okay, so if I were going to, there's a couple things you can think about when you are working with kites. One is that we've got a big isosceles triangle here, so this other way. Here we've got an isosceles triangle here and an isosceles triangle here. So that's one way to think about it. So since it's isosceles, we know that these angles here are congruent, and since this is an isosceles triangle, we know that these angles are congruent. Okay? Then another way to think about it is every individual triangle makes a right triangle. So like this is a right triangle, here is a right triangle, this is a right triangle, this is a right triangle. And we can pull them apart to solve if we need to. Okay? So like in this example, FEJ, this one, here is 25. Okay? And FJG, FGJ is 57. So this angle is 57. If we're trying to find this angle here, I would pull it apart and do, like, let's say I pulled out FJE. I know that this is a right angle. I know this is 25. So to find this missing angle here, I would say 90 and 25, and the missing angle gives me 180, because I know the insides angles of a triangle are 180. So 115 plus x equals 80, or 180. Subtract 115 from both sides, and I get x is 65. So I know this angle is 65 here. Same thing if I pulled this triangle out. So this is JGF. I know that this angle is 57. So I know that the two acute angles of a right triangle are 90. So I can say x plus 57, that's just another way of looking at it, is 90. So x is 33. All right, and then I can add these two together, 33 plus 65, and that gives me 98. So I know this whole angle is 98, so this whole angle is 98. All right, so that's the characteristics of a kite and a trapezoid.